Hello dear students. This video is addressed to the third secondary classes, Life Science and the General Science sections. We hope that the experiment proposed in this recording helps you to understand more the content of your chemistry lesson. Unit 2 Chemical Kinetics. Chapter 2 Rate of Reactions. Part 2.2 Kinetic Curves. Average rate, instantaneous rate, initial rate. Activity 1. Reduction of hydrogen peroxide H2O2 with iodide ions I- in acidic medium. Objective: plot the curve and use the kinetic graph. Equipment and reagents.
Materials of the experiment: 1 to 150 milliliter beaker, 5 to 150 milliliter Erlenmeyer flasks, 10 milliliter volumetric pipette, a pipette filler or a safety bulb, glass rod, graduated cylinders, 20 milliliter graduated cylinder, 50 milliliter graduated cylinder, funnel, 3 water troughs, a solution of hydrogen peroxide of concentration 0.045 ml -1, a solution of potassium iodide Ki of concentration 0.2 ml -1, a solution of sulfuric acid of concentration 0.5 ml -1, a solution of sodium thiosulfate of concentration 0.05 ml -1, and starch indicator. A burette, and a magnetic stirrer.
Preparation of the reaction mixture. In a 250 milliliter beaker, prepare a mixture of 100 milliliters of potassium iodide solution and 15 milliliters of sulfuric acid solution. Stir the solution until it is completely mixed. Prepare to time the solution while you pour immediately 100 milliliters of hydrogen peroxide solution into the beaker. The reaction taking place is represented by E1. H2O2 plus 2I- plus 2H plus give I2 plus 2H2O. The iodine I2 produced by the reaction is titrated with sodium thiosulfate solution according to the reaction represented by E2. I2 plus 2S2O3 2- give S4O6 2- plus 2I-.
First of all, we are going to prepare a reaction mixture that contains hydrogen peroxide, iodide ion solution, and sulfuric acid to provide H plus in the reaction medium. To start preparing this solution in a 250 milliliter beaker, we are going to measure using a 100 milliliter graduated cylinder the potassium iodide solution. This is potassium iodide. Okay. Transfer this volume into the beaker. Then we need sulfuric acid, 15 milliliter of sulfuric acid. Also, it is measured by means of a graduated cylinder. Still we need the hydrogen peroxide solution, but first of all, before adding the hydrogen peroxide solution to the reaction mixture, we are going to prepare 4 mixtures, 4 LMR flasks. In each flask, we add 150 milliliters of distilled water and 2 milliliters of starch solution. The burette is filled with sodium thiosulfate so that iodine produced by reaction number 1 is titrated by the thiosulfate solution, and finally we are going to record the volume needed to reach equivalence corresponding to each titration at these several instances. The aim of using starch solution is, as indicated, to obtain a dark blue color in presence of iodine, even in small concentration. So when equivalence is reached, the equivalence is detected by the disappearance or the decolorization of this blue color. Before adding, prepare the stopwatch so that we are going to start recording the time at the moment of mixing the hydrogen peroxide solution with the potassium iodide and the sulfuric acid solution. I'm pouring 100 milliliters of hydrogen peroxide into a graduated cylinder. Now, add this 100 milliliters of hydrogen peroxide. The reaction starts. Observe that the color immediately turns yellowish, meaning that iodine is produced. Color is becoming more intense, turns to yellow, more yellow, orange color again, and again with the formation of iodine. This is the reaction mixture where reaction 1 is occurring. This is the reaction that occurs in this reaction mixture. We are going to wait 3 minutes. So, and then after 3 minutes, we are going to take 3 milliliters 10 milliliters of the reaction mixture, pour them in the LMR flask, and then take the iodine formed in the 10 milliliters of the reaction mixture. Okay.
After 3 minutes,
okay, this is 10 milliliters of a solution that contains iodine is taken from the reaction mixture, added immediately into an Erlenmeyer flask containing 150 milliliter distilled water and about 2 milliliters of starch. The reaction is now blocked. Ice water, distilled water, blocks the reaction. Okay, start the titration with thiosulfate solution. Now, solution is decolorized, meaning that equivalence is reached. The volume or the reading of the burette is 2 milliliters. So, the volume is 2 milliliters.
after 6 minutes,
Six minutes. Okay. This is the second titration. Where 10 milliliters is taken, were taken from the reaction medium at T equal 6 minutes. Also, equivalence is reached.
The reading of the burette is 4.8. 4.8. So the volume at equivalence point is 4.8 minus 2.8 milliliters.
After 9 minutes,
Okay. The reading of the burette is 8.4. Okay, so the volume at equivalence point is 8.4 minus 4.8, 3.6.
the experiment is continued. Titration of iodine formed in 10 milliliters of the reaction mixture is performed at the instance of time t equal 12 minutes, t equal 15 minutes, t equal 18 minutes, and t equal 21 minutes. And the following table is obtained. The instants of time are 0, 3, 6, 9, 12, 15, 18, 21. And the volumes VRE in milliliters 0, 2, 2.8, 3.6, 4.4, 4.8, 5.2, and 5.6. The interpretation of the experiment will be done later. So we will finish here. Thank you.